right. Welcome to my presentation. This is for my computer science class 4346 in data analytics. It's a presentation on analyzing the relationship between life expectancy and GDP per capita by Sharif Rashid. First, I'm going to introduce myself. Who am I? I was born and raised in Dallas, Texas and Victoria, Texas. I then served in the U.S. Army as an intelligence analyst for about 5.5 years. With that experience, I gained a lot of discipline and focus. I then moved on to work across multiple industries, including construction, warehousing, and manufacturing. And after that, I rediscovered my passion for computers and data because that was something I was passionate about while growing up. And now I'm focused on data analytics and data science for the manufacturing world. The problem statement for this project. Life expectancy varies substantially across the world. Does a country's wealth, measured by GDP per capita, influence how long people live? This project's goal is to analyze global data to understand the relationship between economic development and public health. The objectives of this study are to download, clean, and prepare life expectancy and GDP data, explore trends by year, country, and income level, and identify outliers and exceptions, finally providing insights valuable for global health. So one of the first things I needed to do was set up my computer, which is a Linux distro of Ubuntu / Pop OS, which I accomplished through the terminal. Just to kind of demonstrate, here's the terminal. And so with that first command to install the Jupyter Lab desktop, I entered it like this. Which since I've already installed, then gave me Jupyter Labs to where I could run a Jupyter Notebook on my desktop, which is this icon here. And then I installed PIP, which allows me to install library packages through that command, sudo apt install python 3-pip. And then I set up my virtual environment for my Jupyter Notebook with the python 3-m mynv and source mynv bin/activate, which activated the environment. And then I connected the Jupyter Lab to the virtual environment through that command. And next I installed the library packages, which were Seaborn, stats models, and a couple others actually that I should have placed there. So my data source for this was Our World in Data, and the reason I chose them is because they're affiliated with it's a research project at the University of Oxford. They aggregate data from major organizations such as the World Bank, the United Nations, the World Health Organization. And it provides clean, standardized, country year data sets which were widely used in academic research and policy analysis. And the methodology is transparent and there's excellent documentation. I'm going to come back to this in a second. First, I want to go back to the data I ended up using, which is ourworldindata.org. And the way I found the data was searching for GDP per capita, which then brings up this result. And then I clicked on download options. And under data, and I use this link right here, the CSV data URL CSV format, and put that into my my Jupyter notebook right here for the GDP. And basically search for the other one the same way, the life expectancy. Which is here. Download options. And data, and once again the data URL, and use that for this notebook. And here is the Python code that was utilized to conduct the modeling, or the basically provide the charts and statistics needed to compare. So first thing is that it needs to be ran in a notebook or Python environment with the install of pandas, numpy, matplotlib, seaborn, scikit-learn, stats models, and pycountry. And so first, these variables hold the URL, and then this variable uses panda to read the CSV file and uses that URL variable. The same thing with this GDP variable. And then later on, you'll see where it prints basically the amount of rows and columns of each file, just to confirm the file is correct. And then we move into basic cleaning. So I just wanted to keep the 3 relevant columns that I saw. So this is the variable, and then these are the columns that I decided that I wanted to take from the CSV file. And knowing the column names, I had to open the files and see what the columns were called. So I got that name from here, and the other one from here. And then I normalized the column names by changing this name to just life expectancy, and this one to GDP per capita. Next, the data types were converted. So from just to ensure that it's an integer, and also panda numeric and that this basically returns a null if there's any errors within that row and that column. And then with this variable, basically using Panda to merge these two new data sets, the life expectancy data set and the GDP. And it basically, with the outer, it just merges every row. And then this is a normalization for basically, if it's non-country, then it cleans it out and drops those aggregates. And with this one, it looks up the country name and uses a 3-letter standardized version. Fix that right there. And ended up filtering the years from 1990 to 2023. And so basically with this start year and this end year, if it's greater than or equal to the start year of 1990 and less than or equal to the end year 2023, then it filters it out for those. And for this, this is where it handles the missing values between the two merged CSV files. So if there's a row missing in one of them, then it'll just basically drop it. This is to help do for the log graph later. And this detects outliers. So we keep everything above the 1% for the life expectancy, and we keep everything below 99%. So anything that's above or below those are considered outliers for the study. And so then the cross-sectional analysis, and we chose a focal year of 2019 for COVID, before COVID. And this is all the code for the scatter plot versus life expectancy, the regression, OLS, and the time series example below. And this saves the different files, and this prints. All right, and so this is the life expectancy versus log GDP per capita 2019. Shows a pretty nice slope here, showing a strong correlation. I'm going to go back to the chart used. The log GDP per capita was used because income differences are extremely large across countries, and taking the log reduces skew, makes relationships easier to see, and better reflects diminishing returns to income on life. And then the time series chart was global average life expectancy and GDP over time. So what you're seeing is the x-axis is the year 1990 to 2023. The left y-axis is average life expectancy, and the right y-axis is average GDP per capita, and the two lines moving upward over time. So basically this chart here. and both GDP, what it means is both GDP per capita and life expectancy have increased globally. Life expectancy rises steadily, and GDP grows more unevenly with dips during global crises. But you can also see that when that they both have a correlation. And then the key statistics that were shown were the coefficient of 5.8, meaning that a 1 unit increase in log GDP per capita is associated with about 5 to 6 year increase in life expectancy on average. This does not mean causation, only association. And the regression coefficient suggests that higher GDP per capita is strongly associated with longer life expectancy, even after accounting for nonlinear scale of income. Key statistic 2 was the R squared, which was 0.715, and about 70, so that basically means about 71.5% of the variation in life expectancy across countries can be explained by differences in GDP per capita alone, and that's very high. And key statistic number 3, p-value, the relationship is statistically significant, and it is extremely unlikely this pattern is due to random chance. And just to highlight the stats one more time, they were right here. All right, and so the final big picture is that the key findings: life expectancy increases as GDP per capita increases. The relationship is strong but non-linear. Diminishing returns appear at high income levels, and economic growth matters, but public health matters too. And that's my presentation. Thank you for watching.